name, by the way?
My name's Lorraine Davis.
Okay. So, which robot did you build?
I built this one. I started it over the summer as soon as school got out.
Okay. Why did you build that one?
Because my previous humanoid, I built it when I was 12 and
How old are you now, 13?
15. 15 now. And I wanted it to be better because I didn't like how I built the older one, so I improved it with all the bells and whistles.
Ooh, like what?
Now it has the side motors, and I'm planning on building the arms. I already have it printed and stuff.
Good job. I love it. Okay. Yeah, I see you have like the one you were talking about last week. You wanted to do the neck motion there, so you got to upgrade. So any questions for Lorraine?
Wow.
Yes?
Yeah, so you 3D printed everything? So
Yeah.
how long did it take you? Just out of curiosity.
This took me the whole summer.
Oh,
How many print failures were there?
Yeah.
Like,
How many times did you have to reprint
Like, how many
things?
times do you have to do each part?
I usually got it right, but some of them I had to reprint because, well, some of them were like, some of them broke and some of them failed at first, but not a lot.
I would say maybe because you're talking about, let's see, 100 to 200 pieces. So I would say maybe 10 of them, but they're not really failures. They're more like she has these screws here, and so she just reprinted it a smaller size so she wouldn't have to post-process as much. So a clearance type of reprinting.
Yeah.
But the Let's Spot Mini and the Let's Spot Taz, we really don't have issues with failing. So.
Very few times, like barely 1%.
Okay. I think we have a question there.
Yes?
What made you decide to want to get into humanoids versus like crawlers or rovers that a lot of people do? You see like a lot of rovers, not a lot of humanoids. What made you want to do a humanoid?
Well, I was inspired. I remember when I built my first one, I was inspired. When I saw the Make magazine, I saw the humanoid that was open source and people around the world were building it, and I thought if other people around the world could build it, why couldn't I? And I really like that. Yeah.
What kind of 3D printer do you use?
Let's Spot Mini and Let's Spot Taz.
Yeah, we started a couple years ago with the Let's Spot Mini. So it's a small printer. So when I bought it, I was thinking I was going to print small stuff. I bought it for me. And she's like, I'm going to build a humanoid. I'm like, oh, okay. And then she started printing, and I'm like, oh, okay. She's really building it. Because it's so big, and our printer is just so small. So, I mean, it's incredible, the French guy that designed it, where he cut up all the pieces into such small pieces that a 12-year-old built it. So I'm still impressed. So.
How are you joining all those pieces together?
Lots of post-processing.
What kind? Is it glue or screws, or what are you doing?
This part, it depends on the piece, but on this part, they were basically put together like a puzzle piece.
Oh.
And I'd have to like file it for hours and hours. Probably the most difficult part was the stomach. It's so difficult to put apart. More difficult than debugging the code or anything else.
Yeah, and I would say she and I have different methods because she tends to use the mallet more often than I do. They fit together, so I'm like very patiently filing them, and I'll C-clamp them together because they kind of press, you know.
Yeah, you
press.
see that too.
Yes, that is true. Yeah.
Between you, how many in moves do you have in total? Or
4.
4? Okay.
But I was actually going to mention that. So, so the first one I built when I was 12. The second one we built for another guy,
And we sent that one to Japan.
It was a collaboration, and we got to go to the Japan Maker Fair as well as the San Jose Maker Fair with the two humanoids. And actually, that kind of led me to this one because 2 years ago at the Maker Fair, we had the double humanoid comedy show. So we would have these guys telling, it kind of, the year before that, it was just her white one telling jokes. And so I took that one and the other one, and we had a box, and it had the loudspeakers, and it was controlling both of them, and they were telling jokes. And people could pick, like, if it was going to be poetry, or who's on first, or hi, or knock knock thing. So that's what we did for the Maker Fair, not this year, but the year before that. But then the humanoid went to Japan. It had its huge legs that also went to Japan. And I'm like, you can't go from a double humanoid comedy show to a single humanoid comedy show. That's just not right or appropriate. So I'm like, well, the Maker Fair in May is coming up. This is too sad of a situation. So what does any mom do? I'm like, well, I'm gonna make another humanoid. And then I'm like, well, you had a separate box that had the Raspberry Pi and everything like that, and the speakers, which actually go pretty loud. And if I turn up the volume here, if it wants to go up, knock.
Who's there?
Oh, you don't.
Is there?
Yeah, it goes pretty loud. So it survives the Maker Fair with all the people. So I customized this, so I would put the speakers right here and the screen over here. So that's our number 3. And I think she got to, she saw her mom working on a humanoid, and like, it's been a while since I made my own humanoid. I was 12. I guess I should make another one. So that's where we're on number 4. So, and then most recently for the Gilroy Maker Fair, I added this where it actually says the words here, so it kind of gives cues, because sometimes it's hard to hear what it's saying. So that's where we're at. Yeah.
I just wanted to let you know that these robots inspired yet another one that is being built.
Oh,
And it's forever the 3D print stuff. It runs all day long.
Oh.
We know
Yes. We are not saying, they have a little routine that says, please make more. We promise we will not take over the world, but you should have fun while you can. That's part of the comedy routine. So, we're glad. Okay?
Very nice.
Yeah.
Can you tell us a little bit about the hardware, the electronics, the software that you've done?
Okay. So these are mostly servos. For the full humanoid, it would take, he has spec'd in there 28. I would assume most of them for the fingers, right? Because the French designer of this, Gail Langevin, has the arms as well as the torso. So you have 2 micro servos here. And by the way, one of them has a camera embedded, so you could do that too. I think both of these have cameras. So micro servos here, a standard servo for the jaw, and then everything below that is the giant servos. Oh, and one thing, you can maybe turn yours around very carefully. So on these, you'll see like there's times where there's 2 motors here, and for the design, he'll have us hack them so that one line is controlling both of the servos. So then that reduces the number of signals. So this one has that one line controlling both of the stomach servos, so they move together. And this controls both of the neck servos, they move together. So the one we sent to Japan in terms of software, it's set up for a Windows system, so you can program it to just like have a conversation. So that's an AMIL, that conversational thing. But I kind of feel like at the Maker Fair, I don't really want to babysit my robot all the time or have it sit there if no one's talking to it. So we kind of it's Raspberry Pi and Python, and we found the Adafruit serial, text to serial. So that's doing the two voices, and then it's just doing the serial communication to both Arduinos here.
I want to stop and then say hello.
Yeah?
So what's next for your humanoid robot?
Yeah, so as I said before, I'm currently working on the arms, and I'm gonna build legs for this one as well, like the one in Japan.
Hi, I'm in.
And because we have a scooter at home, so we can actually drive it around, which is really cool.
So that's where she's trying to work on more. I actually have a whole list of other projects I want to work on, so I'm kind of tabling this until I figure out next year what our humanoid home situation is like, whether we're gonna do Three Stooges or, because right now, we literally have 3 humanoids in our apartment. And it's a small apartment, so, yeah.
Very.
Okay?
Thank you.
Okay.
My name is Charles. This is a work in progress. I call it the X arm. It's designed for the robotic challenge, the robotic arm category. The goal is that have my robot be able to pick up an object anywhere within the reachable space on the table. So what I have is a sonar that's scanning in the front. So let me do a demo. And it can pick up multiple objects, one at a time. I'll be scanning for the second object. All right. So the arm itself is an off-the-shelf product that you can get from Amazon for about $200. But I use my own software. I use Arduino Mega, which has more than one serial port. And that's it. I plan to continue to work on this because right now the action only work within a fixed radius. It's a pre-programmed path of motion. I'm working on the inverse kinematics so that it can extend to more locations within this board. Okay, any questions? It's called Lobot, L-O-B-O-T. Yes.
What kind of motors are those?
Oh, those are smart servo motors, which is similar to the more expensive Dynamixo motor. It's a digital motor, so you can control it with a serial command. You can control the servo position, as well as reading back the servo position. You can also send it to control it by velocity. You can also, it has its own built-in firmware. So for example, to create a very smooth trajectory, you can have all the motor joints move simultaneously at a certain rate. Yeah, so those are the challenges I'm working on to create a very smooth the path. Yes, go ahead.
How many degrees of freedom?
6 degrees of freedom. Currently, I haven't utilized the front gripper's the full capability, like it's able to rotate its wrist to handle objects that's of a certain shape. All right, thank you.
I have a bunch of robot parts that are not part of a robot yet, they soon will be. But I'm getting very close. I'm actually basically done with it. This is another 3D printed project. Marco Werther has the SOPI bot that he's been running around here, and I decided to make one myself because I have a lot of 3D printing filament, and have most of the other parts. So this is where we are right now. So we have, I have six completed wheel pods that are all 3D printed, including the shafts, actually, the rotational shafts here. These are carbon fiber nylon instead of metal, because the plans call for you to cut some 8mm rod and then file it off, and it assumes you either have like a lathe or a drill that can be held into one position and run unattended, and I don't, and I have like a drill, and I almost cut my fingers off a couple times, and I was like, hey, I've got a 3D printer, I don't have to do, you know. So so we have, this is one wheel pod. It looks kind of like a Curiosity kind of wheel, which is, it's supposed to, because it's supposed to be like a smaller scale of the Curiosity class 2020, Mars 2020 rover. So there's that one, and then that's the one that rotates in place, and then this is one of the fixed ones. So this doesn't rotate, it's kind of like one of the idler wheels in the center. So there's 6 of them. This is carbon fiber nylon, actually no, this is carbon fiber PETG. This is, the green stuff is PETG. The shafts, the rotational shafts for the axles are carbon fiber nylon. And these are some cheap motors from Alibaba. And I've got a Dynamixel up here at the top. And it's all held together with heat inserts and M3 screws. So the heat inserts are
brushless motor or stepper? What is that?
no, it's a brush gearbox motor. I don't exactly know. I have like the number and everything on here. I think it's brushed. I think it's brushed. They're pretty cheap. I got like 6 of them for $40 or something like that. They're anyways. So this is a prototype. This will be a kind of a prototype for a larger rover that I'm eventually going to build as kind of like a utility off-road, rough terrain kind of rover. And it's pretty much like I said. It's like the size of Marco's. Hello, yes.
How do you steer it there?
How do we what?
How do you steer it?
Oh, it has a coupler at the top, so there's a servo up the top here that you just, yeah. There's a servo that commands it to turn. So there's corner steering for the wheels, and then the other one, like I showed, is a kind of a fixed idler.
Okay.
So that's that, and yeah, that's so. I'll be in. Yes.
You just talked about carbon fiber nylon for the axles. Is that stock, or is that something that is, say, printable, or what?
It's printable. So this is the name of the filament is Nylon X. I got it from Matter Hackers. So it's actually, did I bring one with me? No, I think I have a PETG sample. Yeah, so it's a type of filament called Nylon X. It's a carbon fiber nylon blend. It is amazingly tough. I really, I tried to like break it between my fingers, even on the creases, even on the joints, and I couldn't. I destroyed 2 Dremel drill bits trying to cut one out the other day. And it just melted, and I couldn't get it off the bit. So I had some doubts initially as to like whether or not it would be stronger than metal, strong enough to basically hold up the weight. I don't have any more doubts about that. It's gonna be fine. I'm actually really pretty happy with this because it's basically, aside from the 80-20 beams that form the frame of the rover, this actually pushes it up to I think about like 90% 3D printed instead of like 70 or 80%. So yeah, and that's a kind of another thing is this that the reason I decided to make this is because it is mostly 3D printed. Since I live in SF, I don't have tech shop or the shop build or anything like that anymore. I really have kind of constrained into like the type of things I can construct. So more 3D printing, the better. The wheels took about 10 hours each to print. The frames are about 4 to 6 hours each. The green parts are about 4 to 6 hours each. Yeah, that's pretty much about it. You can ask me any more questions later. I don't want to take up any more time. Thanks, guys. I should have it assembled for next month.
Yay.